Hi, this is the second episode of my Shoptalk series. First of all, I wanted to thank you guys. The comments and response I got on my JAWS series, where we made the JAWS for my small dividing head, was incredible. I was very happy about all the kind comments I got, and yeah, thank you. So I got very much questions about my Deckel G1L engraving machine I used for this job. This is the machine. The overall configuration is like a knee mill. You have a table that moves in X direction and in Y direction with your feed screws, like on a normal milling machine, like a bridgeboard. And you also have a knee that moves up and down. What's different is, from a normal milling machine, you don't have a standard milling head that's rigid. You have this cutter head on this linkage here that's moved by the pantograph up here. And back on the machine you have a table where you can set up your templates that you want to follow, and you put a stylus in it, and as you move the stylus, the cutter head is moved by the pantograph. Up here we have the pantograph in detail. The pantograph is a mechanical reduction device or transferring device. You can set it up to ratios between 1:1 up to 50:1. Yeah, and you set the ratio on the pantograph by loosening these two clamping screws, and then you can move the cutter head, the position of the point on this pantograph, on this dovetailed bar, and there is an engraving on it that shows you the possible ratios. And same for this one here. Just loosen the screw and then you can change your ratio. Right now it's set to a ratio of 2:1. That means everything I do on the template table will be reproduced by the machine in half its size. Like if I do a movement of 100mm on the template table, I get 50mm of movement on the cutter head. Okay, now I brought you in closer to the spindle of the machine. The spindle sits in this casting, this linkage casting that takes the forces. The spindle has a plunge movement via this lever of about 3mm. That's for when you're engraving and you want to retract your tool quickly between each of the characters you're engraving. You use this function. What you can also do is, if you rotate this lever, you get a fine feed of about 1mm travel. For this movement there is also up here a stop that you can set. This is mostly used for when you're doing engraving on a not perfectly flat surface and you want to adjust your depth of cut just by a very tiny amount. This is very, you get a lot of feel of the movement with this action. And the spindle sits down here. It's driven via a rope that goes all the way back to the machine via a pulley down to the motor on the lower base of the machine. And the rope, what you can do is to unloop this rope and unscrew this top cap. Rotate the spindle around and pull it out. In fact, that's not the spindle that came with the machine. This is the spindle I built. It has exactly the same dimension as the bought one, but it uses ER11 collets because they are way more. Also, the spindle that came with the machine here. Okay, here to compare. This on the left is the spindle that came with the machine. It uses this style of collet. You can get them on eBay from Franz Singer, but they are about 100 euros a piece. So that was no option for me. And I went on and made my own spindle. The spindle has only 2 bearings in it, and the actual spindle itself is a straight ER11 chuck. So I machined the housing and the pulley and put everything together, and now I have a spindle that takes standard collets and runs very good, like the original one. And to put it back, it's just moved up, pressed up and rotated, and then it locks in. It's kinda it's like a cam action, and that holds it in position. And then you just screw this cap back on. And the rope goes back down on the pulley, and this rod that goes back here is for the tensioning of the rope. Okay, now I'm going freehand, so be aware this might get a bit shaky. I wanted to show you the drivetrain of the machine. Here we have the spindle with its pulley and the rope that goes all the way back to this pulley, and it changes the direction of the of the rope down to the base of the machine. I'm coming around right now. The ropes go down to this lower pulley, which is kind of back gear for the machine. You can set different gearings or ratios on it, and below it there's the motor on its swiveling base. And to change the ratios, you just pull the rope off and drop it on the next step of the pulley. This whole mechanism is moving when you move the cutter head. And it always keeps the tension on the ropes. So okay, up here we are at the template table. It's a template table. It has grooves in it that have a dovetail kind of profile. So if you look at them at the templates, they have beveled edges, and they go into this groove which locates them, and you put a stop on each side of the template. Now you're ready to engrave. You move your stylus over, and for using the templates you need as Gordon called them, master copies. you need a pointy stylus for your template, and the cutter head will translate the movement with whatever ratio you set it. This is for engraving. What you can also do, or what I do the most time, I do not very much engraving, but I use it for machining. You can put templates like this on the table, bolt it down, and then you can run a stylus around it. I made this set of styli. These are the smaller diameters, starting by 0.6 millimeters all the way up to 6 millimeters, and if you take a 6 millimeter and you can add these rollers, they go up to 21 millimeters. I have the bigger ones always in the nominal diameter of the end mill, and ones that are 1 millimeter bigger. I use the bigger one for roughing and the smaller one for finishing. So the bigger one gives me a stock allowance for finishing. I made these for a ratio of 10 to 1. So I have 20 millimeters divided by 10, that's a 2 millimeter end mill. 15 millimeter divided by 10 is a 1.5 millimeter, and so on down to, if I use this one, 0.6 millimeters. And these are the styli I use most for my milling operations, because I made most of my templates 10 to 1, as it makes it much easier to measure them. So that's it for my Deckel G1L engraving machine. I hope this answered some of your questions. If you have any more, feel free to put them in the comments, and otherwise, thank you for watching.